So in this example, we are given that the segments AB and CD are parallel and that angles A and C are congruent. And we're supposed to prove that triangle ABD is congruent to triangle CDB. And how are we supposed to prove it? By using one of our congruence postulates or theorems, SSS, SAS, ASA, AAS, or HL. Which one is it going to be? Okay, and here you see a little table or a T account that we use to put down our statements and our reasons. Remember, we said for proof we have statements and they are telling us what is congruent, and we have the reasons that tell us why those things are congruent. All right, let's start with the things that are given. We are given that segment AB is parallel to segment CD, and we are also given the information that angle A is congruent to angle C. And what's the reason for that? The reason is plainly and simply that it has been given to us. And when something is given to us, we do not have to prove it. Let's also go ahead and mark the things that we have now and that were given to us. We know that segment AB and CD are parallel. We already see that arrow here. These two segments, parts of these two lines, are parallel. And angle A is congruent to angle C. What else can we find out from this diagram? Knowing that A, B, and CD are parallel and looking at our segment BD, that looks like a transversal, right? And if we have a transversal that crosses two parallel lines, we have all sorts of angles, and we can say that these two angles have to be congruent. Which two angles are we talking about? Let's be specific here because the B and the D are the vertices of several angles. Angle ABD is congruent to angle BDC. And the reason for that is, did you remember where those angles are? They're between the two parallel lines on the inside and on opposite sides of the transversal. Yes, indeed, they are alternate interior angles. Well, the first thing that springs to my mind is that this segment BD is actually part of both triangles. BD or DB, doesn't matter which way you call it, but that is congruent to itself, isn't it? Segment BD is congruent to segment DB, and if something is congruent to itself, if you are looking into the mirror to see the same thing, you see your reflection, this is of course the reflexive property. Okay, so let's see what we have found so far. We have a pair of angles that's congruent, and then we have another pair of angles that's congruent, and we have a side that's congruent. Let's also mark these in our triangle up there. Angle A is congruent to angle C, so angle C is one of the ones we have. We have angle ABD and BDC, so that's this angle. and we have the congruent side BD. What we did not find out is how long this side is, or this side, or this angle. And those we mark with X's, so now we know which way we can go. Going from A, we cannot go across two X's, so we go from A to S, and that means we have used our angle side theorem. So we are able to prove that triangle ABD is indeed congruent to triangle CDB, and we've proven that by using the angle side congruence theorem. Great job, you guys. And now let's go to the next example. Here in this example, we are given that segments AB and DB are congruent, and C is the midpoint of AD. And again, we're supposed to prove that triangle ABC is congruent to triangle DBC. Let's, as usual, write down the things that were given to us. We were given that segment AB is congruent to segment DB, and that C is the midpoint of AD. Those things were given to us. We don't have to find any other reasons why they would be true. But let's make sure that we mark all those things. The congruence of AB and BD has already been marked. And now let's think about the midpoint. C being the midpoint of segment AD. What does that mean? Remember, the midpoint is right in the middle of a segment, and in a way cuts that segment in two halves. So that means that AC has to be congruent to CD. Segment AC is congruent to segment CD. And why is that so? Because C is the midpoint, and that's essentially the definition of a midpoint. What else do we have in our picture that we can figure out? And yet again, the reflexive property helps us out. We have segment BC that's part of both triangles. Segment BC has to be congruent to itself. Segment BC is congruent to segment BC, and that is based on the reflexive property. So let's see what we have. We have segments AB and DB that are congruent, so we have one pair of sides that are congruent. AC and CD are congruent, another pair of sides that's congruent, and BC is congruent to itself, and that's our third pair of sides that are congruent. So now we can prove that triangle ABC is congruent to triangle DBC based on the side congruence postulate. Okay, for your summary, I want you to spend a few moments and write down in your own words, why is it useful to write a two-column proof the way that we have done it in the last couple of examples. That's it for today, and I will see you in class.